Okay, so the problem we're going to be doing is the integral of inverse cosine x times dx. This problem can also be ran as the inverse cosine of x times 1 times dx, which will make it easier later. The part that I've underlined and I'm continuing to underline is an inverse function, so we're going to use that as our u. In the whole, in the, like the I-L-A-T-E thing, I comes first and I is inverse, and that's an inverse. So that's why we're doing that. Once we identify our u, we're gonna make the little square thing, the cube thing, the four-panel square, whatever you want to call it. We're making that thing. And after that, we're gonna go find du. The derivative of inverse cosine is equal to negative. Oh, what just happened? 1 minus x squared. 1 minus x squared. So after we found du, we're gonna identify dv as the other portion of that. So in this case, it's gonna be 1 times dx, and then the integral of dv is gonna give us v, and in this case, the integral of 1 times dx is equal to x. So we're gonna get to the problem. We're gonna get v equals x. Now we have our whole thing complete. Once we have u, du, v, and dv, we're gonna plug that into the equation. The integral of u times du is equal to u times v minus the integral of v times dv. Du, my bad. I've corrected my mistake. It's now the integral of v times du. Thanks for sticking with me. X times dx. So now I'm just plugging in my u, du, v, dv. So that's going to be the integral of inverse cosine times dx is equal to the inverse cosine x times x minus the integral of x times parentheses negative 1 over 1 minus x, the square root of 1 minus x squared. Dang, that's a lot to say. So on the next part, simplifying it and putting it as inverse cosine of x times dx equals the inverse cosine plus the integral of plus the integral. Why can't I speak? Plus the integral of x over the square root of 1 minus x squared times dx. Thank you. So now we have to do substitution. For my substitution, I use w. So we're gonna have w equals 1 minus x squared, which means the derivative of w over dx is equals negative 2x. So dx is equal to dw over negative 2x. Negative dw over 2x. So now I've rewritten the problem a different way, or I'm working on it. The integral of inverse cos x times dx plus x over the square root of w times dw over negative 2x, which the x's will cancel out in this. So this is going to equal x. So this is equal to x times the inverse cosine of x minus 1/2 over, minus 1/2 times the integral of 1 over the square root of w times dw. So I'm going to rewrite this out because 1 over w can be written as w to the negative 1/2. It can be written as w to the negative 1/2. So now I simplify it out further to x times inverse cosine x minus 1/2 times 2 dw to the 1/2 power, which can then be written as x times inverse cosine x minus w to the 1/2, which can then be written as x times inverse cosine x minus 1 minus parentheses 1 minus x squared, because we substitute to the 1/2 because w is equal to 1 minus x squared as I started. a second ago. The final answer is then x times inverse cosine x minus the square root of 1 minus x squared plus c.